Yo, 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 Cola Math students, it is Mr. Knight. We are going to continue on with integration. We are in the midst of it and the thick of it. Let's try to get our way out of the woods. We are looking at the curve and the y-axis, specifically looking for the area between a curve and the y-axis. So you'll see an example problem similar to this one. It says, find the area between the curve, y equals x minus 1, and our y-axis between y equals 0 and y equals 4, so this shaded region right here. Now, before, when we were looking between, like the area between a curve and the x-axis, we kind of went through the motions of thinking about a bunch of rectangles being multiplied together and added up to give us an approximation for the area under a curve. Well, now if we look at this, we're actually looking at this small change in y times our distance x right here. So really what that boils down to is, since we're looking at the area between the curve and the y-axis, we actually have to change our approach just a little bit when it comes to integration. So we know that if we had an infinite amount of rectangles and we sum them all up, we would get the area under the curve. And if we did an infinite amount of these guys, we would have the integral. Okay? So really we get something that kind of looks like this. Now, notice it's not dx, it's dy, because we're going between the curve and the y-axis, right? So I have to change this little change in y right here, okay? Now also, I can't just use x. This is just right now a placeholder, right? Normally our curve, we would put x minus 1 in right here, but because we're talking about y, I need to change it up and solve for something in terms of x. So if I rearrange this guy, I get x is equal to y plus 1. So that's actually what I'm going to integrate because I'm plugging in y values now, right? These little changes in y. So I'm going from 0 to 4, and I'm going to integrate this like I have before. I get 1/2 y squared plus y, and I'm going from 0 to 4 on my bounds, and I find that my area is 12 units squared. And that's really all there is to it. So in review, kind of the only changes that are going on with these problems are our bounds and the equation of our curve. So the a and b bounds, those are on the y-axis now. And it's going to tell you, hey, find the area between this curve and the y-axis. So now you can know, oh, hey, we're going to set it up like this guy, right? Okay? And our bounds have to go on the y-axis to 0 to 4. 0 to 4, right? And I changed the equation of my curve in terms of something, in terms of x, which I got was x equals y plus 1. So I plugged y plus 1 into my integral, and then I took the integral with respect to y. So let's see another example of that, okay? Because really all these problems are pretty much like that, okay? So if I ask you find the area between the curve y equals square root of x and the y-axis between y equals 0 and y equals 3, again, you're going to see that your curve, if you were to sketch it, would look something like this. And we're going from 0 to 3. Okay, so I need this blue area between the curve and the y-axis. So I set up my integral. Again, I'm using x, just some kind of placeholder. So I'm going from 0 to 3. And I'm going to change this to something in terms of y. So looking at this guy, if I take the square of both sides, I get y squared equals x. So I want to actually use y squared for this curve because I'm doing it with respect to y. And so I do the integral of that guy, 1/3 y to the third, and then I evaluate from 3 to 0. I find that I have 9 units squared of this guy. This is a really short lesson, so these problems shouldn't be too bad for you guys. Yeah, good luck on it. Let me know if you need any help on it.